Hey friends, welcome to my channel, and in this video I am going to discuss about Sonogashira coupling and the Berzman cyclization reaction. These two topics, they are very important for any competitive exam and your general organic chemistry also. So let's start today's topic. So previously in the reactions of the organometallic chemistry, I discussed about the Hake reaction and the other cross-coupling reactions like Negishi, Suzuki and so on. But in this video I am going to discuss about the Sonogashira coupling. This is slightly different from the other cross-coupling reactions because it doesn't need organometallic compound from previous. You can generate organometallic compound in situ. So what is Sonogashira coupling? So it involves an alkyne. Let's say you have a terminal alkyne like this, and along with it you have an aryl halide, or you may have some vinyl halide, and you are reacting it with in presence of palladium 0 and copper 1 catalyst, and along with that a base is needed. Generally a secondary amine is used. So if you react these two partners in this particular condition, you will get this cross coupled product. So you can see this aromatic ring and this terminal alkyne, they coupled with each other to give you this product. Now what is the mechanism of this reaction? So what is the different? First you have to notice is that normal reactions like your previously I discussed Suzuki reactions or your Negishi reaction or your Steele coupling reaction, that involves a partner like Rm, that is a organometallic compound you needed for that reactions. But in this case you can see the normal alkyne itself can undergo the reaction. You don't need any organometallic compound. So now what is the mechanism of this reaction? So first you can see this is alkyne, and you know the hydrogen of this alkyne is pretty much acidic because it is attached to a sp carbon atom, and sp carbon atom which is electronegative, so it will withdraw electron that makes this hydrogen acidic. So in presence of a secondary amine, it will be deprotonated to give you this anion. Now you have copper iodide in your reaction medium. So this alkynyl, this is called alkynyl anion. This alkynyl anion can bind with this copper to give you this alkynyl copper iodide. So this is now alkynyl copper. So this is a salt, copper salt. This is a alkynyl salt of copper. So this is the active reagent in your reaction medium. Now as discussed in the previous cross coupling reaction, the first step is same, that is this. Let's say you have this aromatic halide, so it will undergo oxidative addition with this palladium 0, and again I mentioned that it is not the palladium 0 which is used in the reaction. Palladium 2 is used in the reaction, and the base present in the reaction medium, that will reduce palladium 2 to palladium 0. It is the active reagent. So now if it undergoes oxidative addition, you will have this aromatic ring, and here you have X. Now you have this copper partner, alkynyl cuprous partner. So they now exchange the ligand. So this is the same step as for the other cross coupling reaction. So these two now exchange their ligand partners. So you will have palladium, here you will have Ar group, and now here you will have this group. So other two ligands will be there, L ligands, and it is palladium 2. One thing you should mention is it is palladium 2, it is also palladium 2. Two other ligands are there, and now you can see this group and this group, they can undergo reductive elimination. So this is the step of reductive elimination. If reductive elimination occurs, you will get this compound, and again palladium 0 is recovered. So it is a true catalyst because at the end of the reaction the palladium 0 is recovered. So this is the mechanism of the Sonogashira coupling. Now if I talk about the stereoselectivity or the stereospecificity of the reaction, that is very much important. So let's say you have these two substrates where you have chlorine, the two chlorines of this vinyl chloride or vinyl halide, these two chlorine are seized to each other. So when you react it with in presence of palladium 0 base, that is amine base, and copper iodide, and in this case let's say this is any R, this alkyne is your another partner. So if you react these two partners in selective way, that is one equivalent of this compound will react with it, you will get this product. Okay, so this product is 99% you will get. You will not get this one. This one you will not get. On the other hand, if you react the same thing, the reaction condition is same. So if you react this trans compound, you will exclusively get this trans product. You will not get this cis product. So you can see from cis you will get cis, from trans you will get trans. So this reaction is a stereo specific reaction, because if you follow the reaction mechanism, the reactive elimination step and the oxidative addition step, that all steps, in every step the stereochemistry of the center is retained. So that's why you get the stereo specific outcome. Now one of the reaction after this Sonogashira coupling, one of the very important reaction that can happen is that whenever, let's say, you have this same type of vinyl halide geminal, this is called vicinal vinyl halide, and let's say you are reacting two equivalents of your this compound. This is into 2. So 2 equivalents when you are reacting in presence of palladium 0 catalyst and copper 1 salt and let's say secondary amine. So then you can get this compound. So both of these alkene partner will be coupled. Or if you do the reaction in stepwise manner, let's say first step you did this R, and this is step 1. In step 2 you put R dashed, this another group, so here you will have R dash. So this type of compound we will get. Now this product itself can undergo a very interesting reaction which is called Berzman cyclization. So in Berzman cyclization, generally light or heat is needed. So if you put light or heat, what can happen is that they can undergo a cyclization reaction this way. So it will produce a ring, a cycle will be produced. Here you have R, here you have R dash, and here you have this diradical. So this is benzylidene diradical you will get. Now in this case, in this reaction medium, a H dot source, that is the H radical source is used, and that can be this compound. This is a quinoid derivative. You can see this is a H dot source. So this dot can take one H, so that will give you first this compound. Here you will read, but still one dot is there. Here you have R dash and R, and this compound now becomes like this. So this dot and another H is there. So then this dot can take another H dot. Actually this is single headed arrow because it is a radical process, and then you will get a aromatic compound from here. You can see this aromatic compound you will get, and from this part also it is get aromatic compound. So this is why it acts as H dot source, because you can see it will give this. So if you draw it by full conjugation, another resonance structure which is benzene ring, nothing but a benzene ring. So this is why it can act as H dot source. So this is how you get a benzene derivative. So this is called Berzman cyclization. So this is a very important reaction after Sonogashira reaction. It is frequently used to synthesize many drugs. Okay, so this is what the Sonogashira coupling is. So basically Sonogashira coupling, you have to remember that an alkyne and a aryl or vinyl halide coupled to each other, and there is no need of any organometallic precursor. It is generated in situ. So I think I'm able to explain the full aspect of the Sonogashira coupling to you. And thank you for watching. If you like the video, then share this video with your friends, and best of luck for your exam. Thank you for watching.